Okay. Good evening to everyone. Voice is audible? Okay. Thank you. Okay. So in this class we will discuss two important topics. One is a convolution theorem. Another one is a Parseval's identity. Yesterday we discussed the properties of Fourier transform. So convolution of two functions and convolution theorem and the Parseval's identities are most important uh, to solve the problems. So once we prepared these results, so tomorrow onwards we will solve only the problems. So first, the definition of convolution of two functions. So you studied convolution of two functions in Laplace Laplace transform also. Okay. So convolution of two functions f of x and g of x is defined as f star g is equal to 1 by root 2 pi minus infinity plus infinity f of x into g of x minus t into dt. So this is the definition of convolution of two function. So next convolution theorem statement. Convolution theorem, or sometimes it is called energy theorem. Energy theorem, or another name, Fulton theorem. Okay. So write down the statement. The Fourier transform of actually Fourier transform of f of x convolution g of x, which is equal to Fourier transform of f of x into Fourier transform of g of x. So this is the statement of convolution theorem, or you can say this is equal to function of s. This is another function of s. I'll say g of s. So this is a statement of convolution theorem. Now I'm going to give a proof. So some of the students are asked whether the proof will be asked in the question. Yes, proof will be asked in two more questions, surely. Okay, we can expect one question. But in big question, usually they don't ask proofs. Okay, they don't ask proof, but it is better to know. It's all depend upon question paper setter mind. So 99 percentage we don't expect proof in the part B. Okay, now first I'll take the left hand side. Fourier transform of f of x star g of x, which is equal to, by definition, this is what, 1 by root 2 pi, 1 by root 2 pi minus infinity plus infinity f of x convolution g of x, close the bracket, and then e power isx into dx. So first I use the definition of Fourier transform. Next I am going to use the definition of convolution of two functions for f star g or f of x star g. I am going to write this one, the next step, which is equal to 1 by root 2 pi minus infinity to plus infinity F of x star g of x is what? Again 1 by root 2 pi minus infinity plus infinity minus infinity plus infinity f of x into g of x minus t into dt and then we have what? E power isx into dx. Into dx. Okay. Now, so first you are integrating here with respect to t and then with respect to what? X. Now I am going to change the order because the limits are both the limits t and x are from minus infinity to plus infinity. So you can merely change the order first with respect to x and then with respect to what? T. So in the previous one, okay, I'll take this is t. Okay, f of t. Uh, okay, I think here I done it. I done the mistake here. Here it is not x. This should be t. F of t into g of x minus t. So in the next slide also this should be what? T f of t. Okay, wow. So now I'm going to change order first with respect to x and then with respect to t. So 1 by root 2 pi minus infinity to plus infinity. Okay, wow. So here now with respect to t. So that's why I'll take f of t outside the integral. Now this is x. Okay, wow. Here x is varying from minus infinity to plus infinity. What you have remaining? 1 by root 2 pi. 1 by root 2 pi I'll keep here. Okay, 1 by root 2 pi. 1 by root 2 pi I'll keep it here. Minus infinity plus infinity. F of t I wrote here into what? G of x minus t into first dx. Okay, and then okay, x. So first e power isx also I'll write here. E power isx into dx and then dt. The bracket like this, and then with respect to t. Okay, so here I used the change of order of integration by changing the order of integration. Changing the order of integration. Please wait a minute. Okay, so now which is equal to 1 by root 2 pi 1 by root 2 pi minus infinity to plus infinity f of t into 1 by root 2 pi. Okay, so actually this is nothing but Fourier transform of g of x minus t. So Fourier transform of g of x minus t is what? 1 by root 2 pi minus infinity plus infinity g of x minus t into e power isx into dx. So this is Fourier transform of g of x minus t into into dt. So now I'll close this bracket also. Now this is equal to 1 by root 2 pi minus infinity plus infinity f of t into. So yesterday we discussed the shifting theorem. So Fourier transform of f of x minus a is e power is a into some function of s. So using shifting theorem, we can write e power I st into function of s. So here I have g, that's why I'll use function of s is instead of capital F of s, I'll use uh, g of s because here I have small g of small s into dt by using shifting theorem. Shifting theorem. Okay. So next step, g of s is independent of t. That's why I'll take it outside the integral. So which is equal to g of s. What is remaining? Minus infinity plus infinity f of t into e power ist into dt. Minus infinity to plus infinity f of t into e power ist into dt. So this is nothing but 1 by root 2 pi. I think I missed. Okay, 1 by root 2 pi. I should write here 1 by root 2 pi. Okay, wow. So this is equal to g of s into the remaining thing is a Fourier transform of f of t. Fourier transform of f of t. Or you can directly write that is a function of s. F of s. So that's all. So the left hand side is what? The left hand side is you can see here Fourier transform of f of x convolution g of x. Fourier transform of f of x convolution g of x, which is equal to f of s into g of s. So proof is over. So write a note. So in this note, I am going to write f of x convolution g of x. So then you can write f here. So f inverse of function of f of s into function of f of s into uh, g of s. Okay, f inverse of f of s into g of s. Okay. But what is f of s? F of s is actually Fourier transform of f of x is equal to what? Fourier transform of f of x is equal to f of s is what? F of s. So, okay. So, yes. Okay. Actually, it is better to write like this instead of writing like this. Okay. Okay. This is correct. Okay. So, I'll write f of x star g of x is equal to f inverse of this. But f of x, what is f of x? F of x is f inverse of f of s, f inverse of f of s, convolution g of x is what? F inverse of g of s, okay, which is equal to the right hand side, f inverse of f of s ordinary product into g of s. So this is another result. Okay, so it is better to write this expression on the left side. That is f inverse of f of s into g of s into g of s, which is equal to, write this expression in the right hand side. F inverse of f of s convolution f inverse Fourier transform of g of s. Okay, so this the note is over. Next, we are going to discuss a Parseval's identity. Parseval identity. Okay, so the statement: if Fourier transform of f of x is equal to f of s function of s, then integral minus infinity plus infinity modulus of f of x whole square into dx, which is equal to integral minus infinity plus infinity modulus of f of s whole square into ds. So this is the statement of Parseval's identity. So, proof. Suppose if I done any mistake, please point out. Suppose also if you have any doubts, you can ask to me. Okay, first we are going to prove so first we will prove Fourier transform of f of minus x whole bar means conjugate, complex conjugate is equal to f of function of s whole bar, where f of s whole bar indicate where f of s whole bar indicates, or it means, okay, it indicates the complex conjugate of f of s. Complex conjugate of a function of s. Okay. So now I'll start the proof like this. F of s, I'll start. F of s is equal to Fourier transform of f of x, which is equal to 1 by root 2 pi minus infinity plus infinity f of x into e power isx plus isx plus isx into dx. Okay. So now I am going to take conjugate. So Fourier transform of f of x whole bar. Okay. So that means here bar. Here I put a bar like this. Okay. So now this is equal to 1 by root 2 pi. Okay. Minus infinity plus infinity So f of x whole bar is f of x. Okay. But e power isx whole bar is e power minus isx. The complex conjugate. Now, okay, I think it is better to maintain bar here also. Okay, if it is a real function, then f of x whole bar is equal to f of x. But if it is a complex valued function, we can't say. So that's why I'll keep bar here also. Now I'm going to give the substitution x is equal to minus v. Put x is equal to minus v. So this implies dx is equal to minus dv. What about the limits? When x is equal to infinity, v is minus infinity. Similarly, when x is equal to uh, uh, this is minus, first minus, now this is plus. This is plus infinity implies v is minus infinity. So now here you have what? 1 by root 2 pi. 1 by root 2 pi. Left hand side, I'll write f of s whole bar. F of s whole bar. The limit is from, okay, plus infinity to minus infinity. Yeah, the limits will change. Okay, plus infinity to minus infinity. And then f of x is what? Minus v. F of minus v whole bar into e power minus isx. E power minus isx. And then dx. What is dx? dx is minus dv. So now because of this minus, we can interchange the limits. So which is equal to 1 by root 2 pi minus infinity to plus infinity f of minus v whole bar into e power. I think x is equal to, we don't substitute x is equal to minus v here. So if you substitute x is equal to minus v, then this is what? X is equal to minus v now, e power isv plus isv plus isv. So here also we'll get what? E power isv. So because of this minus only I interchange the limits. So this is what? Into dv. So now this is nothing but, the last step is nothing but Fourier transform of f of minus v whole bar. So I'll write here Fourier transform of f of minus v whole bar, or by changing the dummy variable, you can write instead of v w or y, okay, or x. So I will use x here. Fourier transform of f of f of, don't think I am replacing by this v by this x. Okay, I'm just changing the dummy variable. You can use either x or w, whatever you wish. Minus x whole bar, close the bracket. Here changing the dummy variable. Changing the dummy variable. Okay. Now I call this is equation number 1. So maybe I will write in the next step. Equation 1 is f of s whole bar equal to Fourier transform of f of, I'll take this is equation number 1. So this implies f of s whole bar is equal to Fourier transform of f of minus x bar. This is I call equation number 1. Okay. So next, just now we proved convolution theorem. So by convolution theorem, Fourier transform of f of x convolution g of x, small g of x, is equal to a Fourier transform of f of x into Fourier transform of g of x, or you can write f of function of s into another function of s, g of s. Okay, now from this f of x star g of x, okay, f of x in the note we discussed in the after convolution theorem, in the note we discussed this f inverse of f of s into g of s. Okay. For the left hand side, now I am going to use the definition of convolution of two function. That is 1 by root 2 pi, minus infinity to plus infinity, f of t into g of x minus t into dt. For the right hand side, I am going to use the definition of inversion formula, or you can say inverse Fourier transform. Okay, so for this 1 by root 2 pi, last class we discussed inversion formula, 1 by root 2 pi minus infinity plus infinity, f of s, whatever it is here, you should write f of s into g of s into e power minus isx into ds. So here I use the inversion formula. Now 1 by root 2 pi gets cancelled. Okay, now I am going to substitute x is equal to 0 on both sides. So put x is equal to 0 on both sides. So you'll get minus infinity to plus infinity f of t into g of minus t into dt. So right hand side, minus infinity plus infinity f of s into g of s. So x is equal to 0 and this is 1 into gs. Okay. So now this is a step. I call this is equation number 2. So now what we need to do, okay, first just I recall you what we need to prove. So we need to prove modulus of f of x, the limit is what? Integral limit is minus infinity plus infinity. But here what? Modulus of f of x whole square dx is equal to minus infinity plus infinity, modulus of f of s whole square ds. So modulus of z square means, you know that z into z bar. Okay, wow. So z into z bar is modulus of z whole square. Similarly, modulus of f of x whole square means what? F of x into f of x whole bar. Similarly, modulus of f of s whole square means f of s into f of s whole bar. So I want to prove here, uh, I want to prove g of minus t is f of t whole bar. So then only I will get what? F of t into f of t whole bar is what? Modulus of f of t whole square. Similarly, I want to prove g of s is what? F of s whole bar. Then only I will get what? F of s into f of s whole bar is modulus of f of s whole bar. So with this, now I am going to go to the next step. Since This equation is true for all g of t. I'll write here, since equation 2 is true is is true for all g of t, is true for all g of t, or all g of t. Okay, so take g of t is equal to f of minus t whole bar. So if I take g of t is equal to f of minus t whole bar, okay, I'll write the next step. Since g of t is equal to what? Since g of t is equal to f of minus t whole bar, it took like this. So this implies g of minus t is equal to f of t whole bar. So now I'll start from g of s. G of s is nothing but Fourier transform of g of t. Okay, Fourier transform of g of t is g of s. Now Fourier transform of g of t is what? F of minus t, f of minus t whole bar. Okay, now this is equal to, by equation 1. What is equation 1? F of f Fourier transform of f of minus x whole bar is what? F of s whole bar. So using this, we can write instead of there you have x, here you have what? T. So this is nothing but what? F of s whole bar by equation 1. By 1. Okay. Now I proved g of s is equal to what? F of s whole bar. So now equation 2 implies, what is equation 2? So this is equation 2. Integral minus infinity plus infinity, minus infinity plus infinity, f of t into g of minus t, f of t into g of minus t is what? F of t whole bar into dt, which is equal to minus infinity plus infinity f of s into g of s, minus infinity into plus infinity f of s into g of s, but g of s is what? F of s whole bar into ds ds. So okay. Now, so I'll ask, you know that z into z bar is what? Modulus of z whole square. So this is minus infinity plus infinity modulus of f of t whole square into dt, which is equal to minus infinity to plus infinity modulus of, again this is what, modulus of f of s whole square into ds. So actually again I'm going to check the statement. So here we have what? F of x. Okay, so change the dummy variable, we'll get the result. So if you change the dummy variable, the left hand side, minus infinity to plus infinity, minus infinity plus infinity, modulus of f of x whole square into dx, okay, which is equal to minus infinity plus infinity, modulus of f of s whole square ds. So that's all. Proof is over for Parseval's identity. So I'll stop here. Tomorrow I'm going to start the problem. Maybe tomorrow I'll take the class from 11 to 12 morning. Okay. So if you have any doubts, you can ask to me. Otherwise, we'll meet tomorrow. Thank you, everyone.